Okay, this video is going to go through Charles' law. So as it states here, this law gives a relationship between volume and temperature, and this is going under the assumption that both pressure and the amount of gas are being held constant. So keep in mind that the amount of gas is being measured in moles. So the relationship is the gas volume is directly proportional to the gas temperature, and this can be written as follows. So the volume is directly proportional to the temperature. So what this really means is as my volume increases, my temperature will increase as well. So vice versa, as my volume would decrease, I would see a decrease in the temperature. So Charles' law can be mathematically written as follows. V1 over T1 equals V2 over T2. So just like we saw with Boyle's law, this relates both the initial and my final temperatures. So the ones are representing my initials and my twos are representing the finals. So keep in mind that whenever we're dealing with gas laws and temperature, my temperature must be measured in degrees Kelvin. So to go from Celsius to Kelvin, I'm adding 273. So let's look at this in an example. So a gas is collected and found to fill a 28.5 liter container at 25 degrees Celsius. What will be its volume at standard temperature? So again, just like we did for Boyle's law, I want you to outline all of the variables and the given information that we have in this question. So because we're dealing with volume and temperature, we are using Charles, and we need to figure out V1 and T1, as well as my V2 and T2. So we can fill that out now. Okay, so here in the question it says that it's looking for the volume at standard temperature. So remember, standard temperature in terms of Kelvin is 273 degrees Kelvin. If I look at my initial temperature, I have a little bit of a problem because it's given to me in degrees Celsius. So remember, in order to convert from degrees Celsius to degrees Kelvin, I'm just adding 273. So overall, my initial temperature that I'm looking at is 298 degrees Kelvin. So once I have all this information written out for me, then I can just plug and play into that relationship that we outlined above. So my V1 over T1 equals V2 over T2. So 28.5 liters is my initial volume. 298 Kelvin is my initial temperature. I'm solving for my final volume, and I know my final temperature. So now I can rearrange to get rid of this 273 and bring them to the other side. So I'm just multiplying both sides by 273 Kelvin. So here my units cancel out, K and K. I'm left with liters, which makes sense considering I'm solving for a volume here. So if I plug 273 times 28.5 into my calculator divided by 298, I would get 26.1 liters. So if I think about this logically, remember we said that my volume and my temperature are directly proportional, which means that as my temperature decreases, as I see here, I'm going from 298 to 273, I should also see a decrease in the volume, which I did calculate, 28.5 liters going down to 26.1 liters. So all is good with this question.